In this video we are revising fundamental particles. So our aims from this video are to know the names and properties of the fundamental particles, explain the existence of isotopes, and to know the meaning of mass number and atomic number. So let's look at the three particles that make up an atom, the three fundamental particles, and hopefully this won't be too unfamiliar to you. You should have seen this in GCSE. So first, you can see there is a central nucleus to an atom, and then particles that surround the central nucleus. And the nucleus is made up of two different types of particle: the proton and the neutron. The particle that surrounds or orbits this nucleus is called the electron. And the neutron, proton, electron differs in two different properties: the mass and its charge. And we talk about their masses relative to each other, because if we talked about their actual mass in, say, kilograms or grams, it would be far too small a number to actually deal with in real life. So we just talk about their masses relative to each other. So the mass of a neutron relative to the other two is 1. The mass of a proton relative to the other two is 1. That means that a proton weighs exactly the same as a neutron. An electron's mass is 0, it has no mass. The reason why that can occur is because it can be thought of as a wave rather than a particle, and waves, electromagnetic waves, have no mass. The other property that you have to know of these three particles is the charge. So the charge on a neutron, as the name suggests, a neutron is neutral, and the numerical charge on a neutron is 0. The charge on a proton is positive, +1. Now you can't just put a plus sign, you must say how many pluses there are, if you like, and the charge on one proton is +1. The charge on one electron is -1, and again you must state that it is 1, not just a negative sign. That means in a neutral atom you will have the same number of protons and electrons because their charges need to balance each other out. In ions, where you have a charge on the atom, then you'll have an imbalance in protons and electrons. To try to explain to you what isotopes are, I've shown you here three different forms of hydrogen. They all behave identically in a chemical manner, but they only differ in their mass. So this first one is just normal hydrogen. This second one is deuterium, but its hydrogen is a form of hydrogen but has a different name because, as you can see, it has a different number of a certain type of fundamental particle. And this last one is tritium. Now you can see the only difference between these three atoms is the number of blue spheres, if you like, and those blue spheres or circles represent neutrons. So an isotope is two atoms with the same number of protons, in this case 1 for hydrogen, but different numbers of neutrons, and all that affects is the mass of the atom. It doesn't affect it chemically, it still partakes in the same chemical reactions. So for example, you can get water that's made of deuterium rather than hydrogen. It just affects how much it weighs instead. You may be asked to work out the mass number and the atomic number of a given atom. And to do that is quite straightforward, as long as you know what atomic number and mass number means. So atomic number is the number of protons in the nucleus. The mass number of an atom is the total number of protons and neutrons in a nucleus. So for this atom here, the number of protons is 1, 2, 3, 4, 5. So the atomic number is 5. The mass number is the total number of protons and neutrons. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the mass number is 11. These are different from the relative atomic mass, because the relative atomic mass takes into account all of the different isotopes. And so if you look at the periodic table, you can see that boron in the periodic table has a mass number, if you like, of 10.8. Now that represents its relative atomic mass, taking into account all of the isotopes. So you've got to be careful when you read the question whether you use the periodic table or not. If the question asks you what the mass number is of this atom that is shown, then you would say it was 11, because there are 11 protons and neutrons in the nucleus. If you were asked what the relative atomic mass of boron was, you'd use the number in the periodic table, 10.8, because that takes into account all different isotopes. Now this lesson can be used throughout the whole paper. You must make sure you read the question carefully and use the correct data in coming to your answer.